And this is where we get into something that is very, very important, which is network security. The idea is that we want to ensure that the only people that can see our stuff are those that we want to see our stuff. The only ones that can delete things are the ones that we want to delete things. It may require dual administration if we're just doing just-in-time, just-enough administration to make sure that, oh yeah, you're an administrator, but if you're going to go in and delete the production SQL database servers, yeah, well, we're not going to give you permission to do that. You have to fill out a web page, go in and tell them what you're doing, how long are you going to do it, what tool you're going to use, so on and so on and so on. It goes to another administrator who approves it, and then you get dropped into a group automatically. You have like 20 minutes, you go do your thing, it pops you out, and now you no longer have those permissions. So you really want to do a just enough administration, only give people permissions on what you want them to have. Now there's also all sorts of components that can help bring this out, and probably the one that a lot of people lean on is network security groups. Network security groups, in my opinion, is a poor name, but whatever. It is simply an access control list. You can set this on a subnet. You can set it on a network adapter. And what these will do is you can allow and deny traffic. It's just like a regular firewall where you put in what traffic is allowed and what traffic is denied. Unlike a lot of access control lists that have an implied deny all, they actually have it in there, and you can see it to remind you that if you don't match traffic that's allowed, you're going to be denied. And so you need to make sure that you also put the allows before the denies, because as soon as you match one of those access control list entries, then either allow or deny is going to happen. So if you leave it too open, like say, oh, everybody in this subnet can access this, anybody that has an IP address from that subnet can access it. If I have it too open on the deny and then I have an allow a little bit later, okay, well, as soon as I'm denied, it's not going to check any more entries. So you need to make sure that your allows that you're going to match you're going to match them before you hit the denies. So again, this is, we're going to get more into this in network security groups. Now, we can also go in and do firewalls, and network security groups are access control lists on a firewall, but with a web application firewall, this can be up to a layer 7 firewall. Now, you can integrate this with load balancing. You can also use Azure App Gateway. You can use Azure Front Door, where you are providing a whole bunch of access out there. And because it is a layer 7 firewall, it understands all of the stuff all the way up through layer 7. If you're doing a network security group, it's usually 5 tuples: source IP address, destination IP address, source port number, destination port number, and protocol. But it doesn't know what's actually in the data. It's just looking at the carrier information for the layer 3, layer 4 to go in and make sure that that particular type of traffic is allowed. But with Web Application Firewall, it's a layer 7 firewall, and so it understands. And the big one that everybody talks about is SQL Server, SQL injection attacks, because it's really, really nasty. But if I'm running this through a Web Application Firewall, then it will examine that, and if it sees that this is a SQL injection attack, it can block it, it can notify you, it can redirect it, you can do all sorts of things. There's just tons and tons and tons. Now, they use what is called the OWASP rules. These are open source rules, and it is continuously updated. So if there's something in the wild, they say, hey, you know, we've gone in and we've detected this and it turned out to be malware, that gets updated into OWASP, and then really, really fast, your web application firewalls are aware of it. So here you had a 0-day exploit, and they were able to go in and profile it. And now if that exploit happens to you, they can profile it as well and potentially block it. Now, does that mean that, oh, we can just kick back because we have a layer 7 firewall? Well, you know, there's still going to be things that they haven't quite seen yet. So we do need to make sure that we put all the other components in there. In a lot of cases, you can get third-party solutions, Microsoft solutions, all of that. And these will run in a virtual machine, or they can run as a container, whatever we need. And this is what is known as a network virtual appliance. And so with this, I can have an appliance, and I would set that out as a route destination. And so as the traffic flows out or as the traffic flows in, depending upon how I have it configured, it'll go through that network virtual appliance, and then whatever the third party does, it's going to do that. And, we could have it where it is logging all the activity, transmitting it out to a third party solution. Maybe we have additional authentication and security where it looks for digital certificates, things like that. We can redirect that traffic. We can go in and examine the protocols and the ports and, whatever that third party solution wants to do, you can do that. But another thing that we can do is if I don't have to have any type of public access to this particular data stream, then don't send it across the internet. And this is where I can go in and I can use those VPNs and I can use ExpressRoute. And if you wanted to completely isolate it, I would have a WAN link from a WAN provider go from my on-premise to wherever that WAN provider's point of presence is that hooks into the Microsoft Edge. And so I would use this WAN link to connect up using possibly dark fiber or something, but it's not going across the internet, connect it up into Azure, and then boom, it's all of a sudden into Azure's backbone. So we don't have anything that is leaking outside over the internet. It is either in our network, our WAN provider's network, or Microsoft's network. And it makes it so that we can encrypt the traffic. We can set up automatic routing. We can set up automatic route updates using BGP. We can do DNS solutions, all the stuff that we need to do. But the big point is it is not traversing out the internet. So let's go ahead and look at a network security group. When you're going in with a network security group, you'll notice that we have priority. And this is a golf score. The lower numbers are checked first. But you'll notice that we have at the highest number, it is saying deny anything coming in. This is all inbound. And it doesn't matter the port, doesn't matter the protocol, doesn't matter the source, doesn't matter the destination, doesn't matter the action. We are going to deny. So that is the deny at the bottom. So as I go in and I add additional rules, I need to make sure that I have an allow. And when you do this allow, you want to go from most specific to least specific, because, and the way that I remember that, at the very bottom, this is the least specific you can possibly get to. Anything, anywhere, any protocol, any direction, any protocol, deny. You're not allowed in. So if I want to allow people to do, we'll say remote desktop protocol, or I want to allow people to do secure shell, I would have to have an allow statement before I have the deny statement. So this is saying port 80 out to the internet, and we're sending this out to that application security group. We're going to go ahead and allow that. Here's the data tier. We're using port 1433. We're going to be doing that with SQL Server. Here we're talking about VNet to VNet. Now by default, network. I was going to say virtual network. It's virtual network. Looks like the font's a little big. This is one of the default rules that say if you are coming from a virtual network and you're talking to a virtual network, that traffic is allowed. So if I have a VNet to VNet peering, anybody on this side can talk to anybody on that side. And in that case, if I need to harden particular subnets, I may want to add entries in there that say, okay, even though it says here's something allowed, I'm going to put something in here with a lower priority or a smaller number, which means it has a higher priority, so that we will say, oh, if you're not in this from this particular subnet, we're going to go ahead and block you off. So just remember, Azure is set up so that if you have the connectivity, I can get the packets there, VPN or peering or something like that. As long as I have the connectivity, VNet to VNet, that traffic is completely allowed. Now, some of the things that we had right here is the application security groups, and let's go ahead and talk about those. Oh no, this is network security groups still. So here we are allowing certain traffic and we are blocking other traffic. Now the big thing on this is to remember that when you apply these network security groups, you can apply them to the subnet, but you can also apply them to the network adapter. And so if you do have, let's say that you have a mixed subnet, you have some front end stuff, you have some back end stuff, I can go in and you have to make sure that the protocol is allowed coming in, but then I can further restrict it on the network security group on the network adapter. Now, remember, when you create a network adapter, that exists as a separate entity. There is a selection when you create the virtual machine that says, if I delete the virtual machine, do I also delete the network adapter? Otherwise, you can take a network adapter, disconnect it from one virtual machine, hook it to another virtual machine, and then you'd be able to have that traffic, and anything that's applied to that network adapter is going to be applied to that virtual machine. So Microsoft normally recommends you either do the network security groups on the network adapters, or you do the network security groups on the subnet. They don't really recommend that you do combinations. But, you know, if you need to do it, you just need to make sure that anything that is allowed here is also allowed here. Anything that is blocked here, well, if you're going to allow it somewhere else, then you would go ahead and put it at the network interface card. But if we're not going to allow traffic, for example, we're not going to do port 23, Telnet, I just put that there and say, hey, yeah, Telnet is not going to be allowed out there. All right, now an application security group, this is built on top of network security groups that are in there. And this is going to allow or deny inbound or outbound traffic. And there are limits to the number of application security groups you can have in a subscription, and there's other limits as well. You only specify one application security group as a source and a destination in a security rule. You can't go in and put in multiples in there. Also remember that any network interfaces that are assigned to an application security group have to be in the same virtual network that the first network interface is assigned in. So if I have a couple network interfaces, and the first one is assigned to one called ASG Web in the virtual network, then any other network interfaces that are assigned to this application security group web has to be in the same VNet. You cannot take network adapters that are in different virtual networks and put them into the same network security group. That is not allowed. So all these interfaces would have to be in here. Now, if we specify an application security group as a source to the destination in the security rule, remember that both the source and the destination have to be in the same virtual network. And you see this a lot, for example, on the back end. Maybe we have SQL databases. On the front end, we have our front end. Now, these are actually two separate application security groups, but I can make them the same application security group. However, it is going to probably allow front-end traffic, and then this front-end traffic may be able to bleed over. So you would typically see where people do separate application security groups from the front end to the back end. But if we're going to use sources and destinations on both ends, they would have to be in the same virtual network. We also have the Web Application Firewall. Now, we've talked a lot about this. This is where I can have all sorts of front ends on here. I can do content delivery networks. I can go in and I can have regular applications. I can do front doors. I can have application gateways. And because it's a layer 7 firewall using OWASP, it can detect the contents inside of the data. It's not just all the headers that the layer 3 and layer 4 and layer 2 and all that wrap on it. It is the actual data itself. And that uses machine learning, so it'll go in and identify some of the vulnerabilities that are in there. And as things are updated, OWASP gets updated. And as machine learning says, well, wait a minute, we're usually communicating this way, and all of a sudden we're communicating that way. It'll take it a little while to get used to what your traffic looks like. But once it profiles your traffic, then false positives go greatly down, false negatives go greatly down, and it's learning your particular environment. We also have what is called the Azure Firewall, and this is a firewall. It's highly available. It supports not only network rules, but application rules. You can use it to filter out URLs. Oh, you're trying to talk to Facebook? Sorry, we're going to block you out from doing that. And you can have this firewall as a central location, so all the stuff flows through the firewall, and this can protect not only your virtual networks, but also communications on-prem and to and from the internet. These are going to have static IP addresses. You have full logging, and it will work with a hybrid environment. So I have my on-premise environment here, and I also have all my Azure stuff there. It can protect both as the traffic goes through. Now, we've already talked about Bastion. Bastion host allows me to use a web page, a web browser, to connect up to a server that is in a dedicated subnet. So let me get my head out of the way here. So you don't have to have public IP addresses on your virtual machine, so we don't have to have a public IP address, and we certainly don't want to expose port 3389, even though Microsoft by default says, oh, let's open up port 3389 with a public IP address. We're going to block that. The big thing to remember, the big thing to remember, if you set up a subnet with a Bastion host, it has to have connectivity to whatever server you're trying to manage. And this connectivity could be, oh, they're in a different subnet in the same virtual network, and then it's not that big a deal. Or I have to go in and I have to have either a VPN or I have to have peering set up. And so I would connect up to the public IP address of the Bastion. And if I wanted to do this inside a portal, what I would do is I just go to the server and say I wanted to connect, and then I would say use Bastion, and I tell it which Bastion, and it would verify that I do have that connectivity. And so since I said, oh, I wanted to talk to 10.0.1.5, it would make that connection for me, and then it just looks like I'm doing regular remote desktop. However, I am not receiving raw RDP packets. It's just showing me the screens, the streaming using the web page. So RDP does not have to be allowed here. I don't have to have RDP in my network, so a lot of companies block out RDP. But by connecting to the Bastion, I send the stuff via HTTPS, and then it does the Bastion in the background, and I don't have to go through and expose it. Also, something really nice is I don't have to have an RDP client. I do not have to have any tools. I don't have to have Secure Shell, and I can use this to not only communicate with Windows machines, but I can also use a Secure Shell with Linux machines and things like that. So Bastion is nice. Now this is going to set up a cluster of virtual machines, and again, don't put anything else in there. You also need to make sure that you're not putting network security groups or blocking traffic or anything like that. And you also need to make sure that you do have connectivity. Now, if my connectivity is where, for example, I have this VNet, and I have this VNet, and I have this VNet, and these are peered, and these are peered, and here is my Bastion. So I have a virtual machine here, virtual machine here, virtual machine here. If I connect up to the Bastion, I find that I'm able to go in and communicate to this virtual machine. However, if I try to connect to this one or try to connect to that one, I can't. Why? Questions and answers. Chat it in. So if I set up the peering here, so these two are peered as well, I can go in via my web page, I want to connect to, we'll say VM1, and that works fine. VM2 and VM3, neither one of those works. Why would that be? And we talked about this when we were talking about peering. So if we have this Bastion host and it's connected up and it wants to talk to VNet 2 or VNet 3, it's going to have an IP address that does not match this virtual network. And if, as part of that peering, I did not allow VNet traversal, so destination traffic that's not from my network, it will just go away. So what I'd have to do is I'd have to say allow traversal. I'll say that's fine. And if I wanted to talk to VNet 3, I would also have to allow traversal here. And then we would be able to connect to number 2 and number 3 and number 1 and all that good stuff. So make sure that you're aware of it and make sure that you do have connectivity in here. Now, could I use a VPN as well? I could use a VPN. I like using peering because it just takes a moment to set up as opposed to 45 minutes. And with this peering, I don't have to worry about, oh, I'm peered to somebody and you're peered to somebody else, and oh, we have to use a remote VPN gateway. No. With peering, anybody can talk to anybody as long as you have the connectivity or you have traversal set up. So we can go in and do this. Now, this does allow me to do the remote management, and if I need to, I can add additional layers of security where I disconnect the peering from the Bastion network to everybody else, and I could even have a script that automatically connects it and then allows us to proceed, or I can have it automatically disconnect from us when we're done. It just depends upon what level of automation I want to be able to do that. Now, the whole idea here is that I want to be able to manage this no matter where I am, and I want to have appropriate levels of access no matter where I am and no matter where the resources I need to access are there.